So this is my next project, engineering a way to control a Minn Kota PowerDrive trolling motor. I'm going to walk you through what I have set up here for prototyping before going to the next stage of actually creating a board for it. So what I've got here is my Wi-Fi connection for this ESP8266. And I am connected to that device. On the screen you'll see the logs for the Arduino code that's running, and you'll see the logs there on the right hand side of the Chrome browser. The logs, console logs coming from JavaScript code that's running, and then this area here is just the simulation of a I think I have it simulating an iPhone 6. So I'll do a refresh here, and you'll see the code there running and sending the JavaScript files to the browser, and there it's initializing. I've got it initializing the one of the analog GPIOs to 0, so the thing doesn't start up. So the motor doesn't start up when you actually turn it on. So now I'm initialized. And everything is ready to go. So I have a slider here that will be for the speed control, and the way that works is it's actually sending a reading of either anything from 0 to the 123, and that actually controls the voltage that is going to be on the GPIO. So if you look at my development board here, I have some LEDs hooked up to simulate the hardware connections that will be on the motor. I will raise this guy up, and you'll actually see nothing happening. Oh, there it goes. They'll let go of it. So yeah, it's the way this works. The slider doesn't send the value till you let go. So as I move this guy down, you can see the it might be hard to tell it on the video, but you can see the light dim down. So I'm actually, let me back up here a little bit and move the board. So I'm actually moving the slider here. When I let go, it turns it on, and I think I can click and actually bring the light down and actually turn it off. So that will actually control the actual speed on the trolling motor. And then the way we'll turn it on is with the on and off button here. That guy actually turns it, so that's simulating that, turning the LED on. There's a momentary function, I can't remember what that does on the motor. And then this will be the left turn, and this will be the right turn. And you can see I'm confirming everything with the logs that are coming through the pound sign, and actually I'm using the WebSockets to do this. So the pound sign actually causes it to fall into the logic loop for controlling the actually turning the circuit on and off. The actually pressing of the down, which is the D that you see on the last end of there, actually turns the circuit on, and the U actually turns the circuit off. And the letter in the middle, the I, the M, and the L and the R are the different functions over there in the logic that it's actually turning on as well. So the Arduino code has the logic in there too to show me the digital GPIOs that are actually being triggered, so I can see that this taking place. So that's pretty much it. I think we've got the next step is to actually figure out what I need to do with the voltage. This board runs at 3.3 volts, and the board that's on the trolling motor that I removed, this guy was running at 5 volts. So I don't know if I need to have 5 volts or not. I got to figure that out. I think I'm just going to have to hack the motor again and take a look at whether or not the 3.3 volts can actually turn the circuits on and off and actually control the motor with the 12 volt circuits that's on the actually inside the motor, turning the propeller and everything. So that's it. If you have any questions, send me an email or just leave me a message on the post a message on the forum here.